Alright, so hello and welcome. Howdy. Let me, we're gonna jump right into the next problem. Kind of have a, just want to get going. Just keep working. Keep practicing, keep working, see how quickly I can solve these problems. I'm gonna try to, like I said, my goal now is to just spend as much time as I can working through the problems on this website. And then, once I'm done with that, then on the next project, who knows? I think probably, well, there's a lot of different options, different possibilities, things to do. But, yeah, I don't know. I don't even know anymore. Life's hard. Excuse me, life's hard. But anyway, let's keep going. Yep. Given an array of non-negative integers nums, you are initially positioned at the first index of the array. Each element in the array represents your maximum jump length at that position. Your goal is to reach the last index in the minimum number of jumps. You can assume that you can always reach the last index. Oh yeah, okay. Minimum number of jumps to reach the last index is 2. Jump 1 step from 0 to 1, 3 steps to the last index. Alright, so this is a pretty interesting question. 10 to the 4th numbers. So this is probably a dynamic programming question where you'd want to, this is more of the, it's one of those more like straightforward questions, I guess. What you can do is have a, I guess you can go from the back to the front and say, and actually this could be dynamic programming. This doesn't even need to be like recursive, and you could say from the back to the front, I guess what you would do is for each value that you see, all of the, if you can reach the end, right, if you can go off the end, so actually, if you want to get the end, where do you want to go? Reach the last index and the minimum number of jumps. Okay, so the last index obviously is 0 jumps, right? And you would just loop from right to left, and you would say take the smallest value in, I guess, the set of values to the right that you can jump to, and then add 1, and then that'll be the value at the position that you're at, and then take the minimum of all of those, and that'll be the solution to the problem. So this is pretty straightforward. So how are we doing on time? I've seen this question a few times in a few different ways, so that's why I was able to solve this kind of quickly. So let's try to do it fast. Ret is going to be the size nums.size 0, or int, we're going to have equals, let's do just int, let's do numeric here, or limits, I think. I don't know if it's limits or numeric. We'll start with the largest possible. We're going to say standard numeric limits of int maximum I equals, nums dot size minus 1. I is greater than or equal to 0. Decrement I. And we're going to say in an inner loop, j is going to be from I plus 1 to j is less than nums of, it's actually going to be, you can do it this way, j to k equals 0. And we're going to say k is less than nums of I. And we're going to increment k and increment j. And we're going to say if j is equal to, j is equal to, actually, yeah. Okay, j equals nums of nums.size minus 1. And then we're going to set nums of I equal to 1 and break, right? Otherwise, it's actually like the minimum value. We should do it another way. We should do, you could do it this way. It's actually better. A better idea. Standard min element plus 1. Just check something here. Oh, nums of I could be 0. That's interesting. Oh, well. If I is just 0, or if, yeah. It's greater than 0. Otherwise, we just keep going. Excuse me. Excuse me. All right. So we're gonna do 1 plus now. If nums of I plus, so I plus nums of I, excuse me, is greater than or equal to the nums.size minus 1, then we're going to say nums of I equals 1 and break. All right. Or continue. Yeah, I could do otherwise, I guess. Yeah, continue is fine. So you jump to the next value. Fair enough. Otherwise, nums of I is going to be this minimum element of, it's going to be nums.begin plus I to nums dot, this is tricky as well. Oh no, we're less than nums.size minus 1 if we're over here, so that's fine, that's perfect. I think I did that on purpose. So nums.begin plus I plus nums of I. There you go. That should be fun. Is that right? It might be plus 1 minus 1 here, actually. I gotta be careful. The reason is, let's see if this executes, and how are we doing on time? 8 minutes, okay. Oh, what's this? Ret with a different, result, not ret, res. I did this wrong. Not nums of I, nums result. I'm going to say result of I is equal to result dot begin. I think res and ret probably is not the best. We could just say v, something like this. It's probably better. Yeah, v and yeah. So we'll call it v. So now we update v of I to 1 plus the minimum element of all of the options that we could jump to. Begin plus 1 plus I rather. So itself obviously would be 0. This could be plus 1 here, and then I think this also is plus 1 because, and let's just say we could say jump. Let's do that too. That's a little bit better. little bit cleaner. And the reason for this is the jump. If the jump is 5, so if you're at index 0 and your jump is 3, then you can go to index 1, 2, and 3. Is that right? Jump 1 from 0 to 1, and then 2, 3, 4. So 1, 2, okay, yeah. So whatever the index is, whatever I is, plus the jump is going to be, the jump is 2, you would go index 0, jump is 3, you go 0, 1, 2, 3. But the problem is that this actually is exclusive on the right side. It goes sort of one past, I guess. Oh. One more detail. Ret equals standard min of ret and VOI. Yeah. Forgot that. I think it should be actually at the end here. I don't think we need to put that there. Yeah. That's it, I think. I think we can just go for it. I'm afraid to go for it. Probably want to go through some test cases, but I think we got it. Oh man, I'm so bad at this. I don't like going through all these test cases. Just should be. Oh, that's silly. Oh, I see. Yeah, I guess if the jump is 0, yeah, I guess that's fair. Yeah, yeah, yeah. I guess in that case you would say something like, this would be 0. I mean, yeah, I mean you can start everything here with this, I guess. I don't know. I'm actually not sure exactly how I would want to handle that case. I probably should have thought about that a little bit more before submitting. It's annoying. Should we go for it? Probably. Oh, come on. Excuse me. Tricky edge cases, man. Tricky edge cases. Yeah, the last one should just be 0. That's so annoying. Yeah, that's kind of what I was thinking about it. Like, I don't know. There's something I need to do to handle the certain edge cases, I guess. I don't know. Yeah, these are the kinds of things you would probably just test it. Of course. All right, that's dumb. How do you think about it? I don't want to say I hate these questions, but I'm so annoyed. I'm so annoyed. I really don't like it. It's like a test of discipline or something, where it's like you just need to go through all the tricky cases. That's really obnoxious and time consuming, and yeah, just don't want to do that. Just don't want to. Sick of it. Sick of it. Sick of all this. Sick of it. Whatever. It's fine. Yeah, I kind of knew that was gonna be an issue. Like if it didn't have any zeros in here, I think we were fine. But because there's zeros, it gets really a lot more complicated. Fair enough. Fine. And obviously, you could just run a bunch of different test cases, and you'd realize that it doesn't handle these cases properly. All right. So anyway, one issue is that if you're already at the last index, that should be 0. I think 0 hops. And actually, you shouldn't even really process that one. right? It should just be 0. V of v dot size minus 1 is 0. Or actually, no, wait, hold on. You don't want to do the, no. Okay. All right. Yeah. Minimum of ret and v of I. You just look at the back. So this is irritating, to say the least, because there are so many issues here. There's like a bunch of, it's pretty hairy pretty quickly. You need, if you're, the last element should be 0. The problem is you're taking minimums over things that there should be a 0 in there, so it gets confusing. It's actually also, why, this is actually wrong. This is very wrong. This should be, yeah, these should be maximums, right? And then they get updated as you go, right? So they're just too big. They're always too big, basically infinite. And then you just say the last one is 0. You don't process 0 though. You don't need to. You could start ret at a maximum, and well, you could. The first index is what you want. You actually want. Actually, I did this wrong. Hold on. I don't know. This is confusing. You don't actually. That's not what you want. You want v of 0. That might be part of the issue here. So annoying. So I think can always reach the last index. Okay. I'm so sad. I'm so sad. I don't want to say I hate these problems, but like, kind of hate these problems. Excuse me. They're really not that hard, but just programming them could be such a pain in the neck. All these slight details that are just really irritating. It just requires time to think it through. All right, so here's the problem. So we don't actually need this at all. This variable. What we're saying is we can start from the back and say it's going to be 0, and we're going to say from that position. Now we don't actually need to process that position at all, actually. So we probably shouldn't, right? We should leave that. We're going to say jump. If there is a jump, if there's no jump here, then we actually should make this like, I guess, infinite, right? Like it should just pretty much be the max minus 1. Problem with what can happen here is if we make that the absolute maximum and then we add 1 to the absolute maximum, then we have an issue. But I think otherwise you'd say v of I. We'll make it maximum minus 1, I suppose. Fortunately, we do have a bound here that we can use, but really you'd want to actually add a little bit of code here. So we'd say sort of best. I guess best approach. And we'll say if best approach is less than standard numeric limits int max, and then we can say v of I is equal to best approach plus 1. Otherwise, v of I is the maximum. There is something else here, which is, what are we doing? Excuse me. If the jump is 0, then I think you should set them. I'll also set that to basically impossible to. You can't move anywhere from there. You'll never be able to get to the end from there. So, okay, something like this. I think we just had it wrong before. I don't know. Hopefully not. Now we should run some test cases. I'm so annoyed, man. I don't know. I'm just aggravated. Who knows? Who knows? Random test cases, I guess. I think this one, invalid test case. Yeah. Alright, what do we get? Let's add a 0 in here. Yeah. That's better. I think there is some issue with like whether you can get to the end. Brother, I think I hate these questions so much. Just thinking about it, it's so frustrating. They're not even hard. They're just tricky, right? They're just tricky. That's it. Not even hard. They're just tricky. All these different, look at all this, look freaking if-else statements here. I guess they're designed to be like that, but it's so frustrating, I guess, because you practice so much. It's been years. It takes so much time. Yeah, forgive me. Irritated. What I'm trying to do is I'm wondering if you ever can get into this situation in the first place. That's sort of what I'm looking for. It's like, is where all of the jumps you jump to give you infinite value. I think it's possible. Yes, it is definitely possible. Yeah, because you can go like something like this. So you can have 0, yeah, definitely 0, 0, 0, 0, right, and then 0, 1. Right, try something like this. Add a couple of zeros here, and then if you have 1, 2, 3, 4. Let's say this jump in the middle goes like 3, right? So 1, 2, 3. Can't get anywhere. But all the way over here, you can make one jump right to the end. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. You can jump 9. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's try this. Oh, it's still correct. All right, I think it's correct, but yeah, it is. You could get in this situation here. There we go. All right, whatever. Okay, great. So it took forever and failed it a bunch of times. 20 minutes. Should have taken me like 10 minutes because I've seen this question a few times. Or a similar question. Yeah, this is so annoying. Throwing all these extra if-else statements in here. This is like very unclean and really irritating and aggravating. I would say genuinely aggravating. I think part of the issue is that I forgot to say that the solution is supposed to be in the first spot. But yeah, it's a dynamic programming solution. It's pretty straightforward. Let's see what the discussion says. Let's see what other people have for their code. One loop, greedy, BFS. BFS is pretty good. 10 lines. Excuse me. What's the word for BFS? It's breadth first search. Step, start, end. Alrighty. I equals start, and it's greater than n minus 1, return step. This is interesting. I don't know if I would do it this way. Huh. Step is 0, start is 0, start end is 0. Well, end is less than n minus 1. Step plus plus. Max end equals end plus 1. How is he doing this? I less than or equal to end. I square that equal to n minus 1 return step. What is going on here? Max end equals the maximum of the max end and I plus nums of I. Oh! I think I understand what he's doing. He's saying basically jump as far as you can in the first starting position. But the thing that's, yeah, and then, okay, update to the start and the end to end plus 1, end equals max end. Okay, I think I understand. So he's saying this max end gives you, I'm actually not sure. Your nums of I could be 0, right? The problem with this is, I think what's going on here is that you want to figure out the furthest that we can jump. I don't know if this is correct, actually. Not using unclean if statements. Yeah, great. Great. Excuse me. I'm so annoyed. I'm so annoyed. I'm just aggravated, irritated, annoyed. I'm not in a good mood. I got a bad attitude. I'm aggravated, I'm irritated, I'm resentful, I'm bitter, I'm frustrated, all those things. It's not good. It's not good. It's a sin. It's a sin. How are we doing on time? 27 minutes? Okay. So, step is 0, start is 0, end is 0. End is less than n minus 1. Step plus plus. So first step. Max end is end plus 1. I don't know where that comes from exactly. I equals start to end, less than or equal to the end. From 0 to 0, I guess, initially. If we're greater than or equal to n minus 1, then we're done. Turn the step. Otherwise, this is also confusing because if n is 1, what are we supposed to get if n is... Hold on. Yeah, it's supposed to be 1, 2, 3, 4. 1, 2, 3, 4. Yeah, so it's supposed to be 0 if you're already at the end, right? I guess. Oh, never mind. I'm sorry. You got that. That's fine. No, never mind. I get it. I saw it. I see it. I suppose it wouldn't be uploaded that much if it wasn't correct. Right, because this while loop would just exit, and you'd have step 0, so you're fine. You have to excuse me. I'm so angry. I'm really bitter. Like, I'm really just a bitter person, I think. It wasn't always this way, but like just extreme disappointment is, it's been getting to me. Just extreme disappointment. It's been getting to me. Anyway, so step plus plus. Step is 0, return step. End is less than n minus 1. Interesting. So I guess once you've quote unquote reached the end, then you gotta exit this loop. So you increment your step. Now you're gonna take the first step. Your max end is gonna be whatever your end was plus 1. Okay, interesting. And now you're gonna say I is start, I is less than or equal to end, I plus plus. So I guess assuming that you can always make it to the end, you're allowed to do this. That's kind of the thing, is that you gotta have at least, I guess, at least one jump. I equals the start to the end, let's equal the end of I plus nums of I is greater than or equal to n minus 1 return step. So once you've reached the end, you can return step, return that value. And max end equals the maximum of max end I plus nums of I. The maximum of... Yeah, I mean, this is basically the furthest you can jump, right? So of all the things that are possible to reach, you want to take the maximum value. All right, I guess that makes sense. From the start initial position, so start and end. And so we set the starting point to n plus 1, wherever end was initially, and then end is the maximum jump. I don't know about this, man. Something about this is kind of weird. This is a little strange. So start to end, and you're going to go over all of your maximum possible jump where you can jump to. But now you're only going to go to end plus 1. Yeah, I mean, it's as simple as like you jump as far as you can each time. I think that's kind of what's happening here. And you only know as far as you can go by checking all the values in that. Now, something that's interesting is, okay, I think I get it. Yeah, I've seen this solution before too, as well. I've actually seen this before. Something similar. The reason why it's true, why it works, is because you do end up visiting every possible jump position. It's just, you're going to, yeah, they call it a BFS. So basically you do like a whole chunk. It's like a level order traversal kind of a thing where you say, here are all the possible jumps that we can reach, and then there's a jump we can take from there. Let's figure out the furthest we can jump given all those possibilities. And then we're going to look at the next section. And that furthest jump is going to define the end of the next section. That's pretty much what's happening. It's kind of breaking this into like a level order traversal. Which is fine, which works. I didn't realize. So yeah, we could code that up ourselves so that we don't forget it. Yeah, this is really messy. All these if statements. That's fair. Fair enough. I probably should have tried that approach as well. This also the approach that he went with also allows you to use less memory. It's not a dynamic programming solution anymore. So let's try that. Let's do that. So int jump 0. We're gonna say like start, end, or begin, or we just say A and B. I prefer that. We're going to say while, or we can use the for loop even. And we're going to say return jump. And we're going to say while B is less than n minus 1. And we said n is going to be nums.size. And what we want to do is increment the jump at each point, and say we're going to say for there's a start and an end, so I equals A, I is less than or equal to B, increment I. We're going to say int reach is going to be nums of I. We're just going to name things differently so it's we have some degree of like some degree of difference between what he had written. Now the max reach, we're going to call it, initially is going to be end plus not end but b plus 1, the end of our range plus 1, and then we're going to update. So if our reach, if I plus reach is greater than or equal to n minus 1, then we can return our step, our jump. That means that we are able to reach the end from here, and we're done. Reach the end. Otherwise, we're going to update our max reach to the max reach and I plus reach. And after we do this, we're going to update our new ending point to the max reach, and we're going to update our starting point is going to be the max reach. And how does this work? It's going to be our starting point. It's not the max reach. It's going to be what we just processed. So it's going to be b plus 1. And then b is going to be this max reach. So we processed b already. So now we're going to update a to b plus 1 to the next value. And then we're going to update b as the max reach. Something like this. And this should be the same routine that we just saw. Is it the same one? I might be wrong. Oh no, there you go. Okay. That's a lot faster. Excuse me. Yeah. I've seen this before, but I didn't remember it. It has a level order traversal. That's fine. That works too. I'm so irritated, man. I don't know. I can't get over it. I'm so annoyed. So upset. I'm so upset. I don't want to go into too much detail as to why, but I'm just really irritated. Just really irritated. It's a lot less memory to use, and it's also pretty fast. Although it's not as fast as it could be, which is kind of interesting. I was expecting this to be fast. Yeah, there we go. That's what we're looking for. Yeah, I guess it's just kind of random, but in some cases it's very fast. Like this is probably about as fast as you could do it. I don't think you can go faster than this. What's interesting about this too is that that it is correct, right? The reason it's correct is it's a level order traversal. So we do visit every single position where we can jump from. So yeah, I'm grateful that we looked at this problem again though, because I remember looking at this way back when. I looked at this a few times, this question, a few variations of it, and it's an interesting question. It's a challenging question, but this is a good approach, solid approach, and I'm glad I got to see someone else to, work through it. All right, so thank you for watching, and yeah, forgive me for being agitated, irritated, frustrated. I don't know, man. There's so many things I'm so aggravated about, I guess, just things I'm frustrated with. All right, so thank you for watching. Talk to you soon. I'm gonna take a look at another problem.